you got?
Honestly, not a ton. But it's like, I've told you before, these are going up on the YouTube channel. So, yes. So, one thing that's going to change now that I've seen that all of you can at least fake the ability to think. I know, right?
Real.
But so I'll make a change in the syllabus for this so that it's clear and there's no mistaking it for administration. So what we're going to start doing is we're going to start working on learning how to use AI as a tool. We're not going to use it to copy answers. We're going to use it for a tool. So one of the things you're going to have to do is if you're using AI to help you with homework or whatever, you're going to have to translate what it tells you into the format we do things in class. So you're going to have to translate between the two. So you can't just copy down what it says. You're also going to have to make sure you're checking what it gives you. You have to be careful. So I can tell you about 20% of the time when I've tested it, it gives the wrong answer. So you're going to need to make sure what it's giving you makes sense. And I will tell you, there's two that are more reliable. So Google's AI is pretty reliable.
ChatGPT.
The ChatGPT is the one that's wrong the most.
Okay.
What?
Snapchat
No.
AI is
Chegg is cheating.
Yes.
Chegg has
I don't have
answers.
That costs a subscription.
Yeah, no. Chegg is not an AI. Chegg is someone who said, look, I've worked out these solutions. Here you go. No.
I got Chegg for him too. I don't think it's continuing now.
Yeah.
It's the last
Also, keep in mind, you have to be careful with Chegg. You guys not remember what I told you about Chegg?
No.
Okay, so there was a period of time, and now Chegg's getting better about this, but it's still happening. So professors got really sick of students using Chegg. So a lot of professors got accounts as experts, and they were giving the wrong solutions.
That's evil.
That's crazy.
Yeah,
That's a lot.
you also have it coming.
You got that kind of time on your hands?
If you're gonna use Chegg to copy your work, you damn right I do.
You can go through my phone.
I
got
personally
Chegg.
couldn't figure out how to use Chegg.
So
Look at my face.
you have to be careful.
Subscription right now.
Now, the two that I've seen that are the most reliable are Google's AI, and then there's a search engine called DuckDuckGo. So Duck AI is pretty reliable.
Wait, are you telling us?
Oh, we like
this
did
is-
the test, but it was just the.
I'm telling you still need to check what it's saying. But I am telling you that ChatGPT has been wrong more often than not.
She said that information only have to do with AI like 2 days, but the rest basically.
You need to make sure anything it tells, that whatever it tells you makes sense. You need to remember your equations. And so another thing that's gonna go along with this is I'm gonna become a lot more strict on you solving for the variable that you're looking for. So it's like if you have a problem where you're looking for velocity, you'd better solve for velocity and give me an equation before you plug in numbers, okay? So you're gonna have to do that. You're gonna have to translate between whatever AI tells you in the format we use in class. So that's gonna be the exercise.
I'm too scared.
Because again, I've seen the solutions that AI gives. I know what they look like.
Gonna be like a separate thing, or is it just like if I'm gonna use it for?
No, if you're gonna use it.
Okay.
It's not gonna be a separate thing. Also, make sure that whatever solution it gives you, it's stuff we've covered in class. And I can tell you, I've had someone turn something in chemistry where they were calculating basically how much of an ionic salt would dissociate in water. I would say Van Hoff factor, but I know that most of you don't even remember what that word is. But they gave me a solution that used an advanced quantum mechanical solution involving activity and all that fun stuff. And they only gave me like a very small portion of the solution because for this certain compound, the rest of the solution reduced to 1. And I was like, where did you get this? And they're like, oh, I was like, that's part of a much larger solution. It's like, so if you get something on AI, it's like, we didn't do that in class, don't use it. translate to something we've used in class. So we're going to start practicing using that as a tool. And since my current syllabus says that you can't use it, I'm going to change that so that if an administrator ever asks, it's like, no, I've made the change. They're doing what they're allowed to do. Because apparently, this is something that's going to be part of our life. And it's funny, I was reading Forbes magazine and I was looking at careers that are in danger based off AI. First off, a lot of labor jobs are in danger. Eventually, McDonald's is going to have no workers. Now, apparently, health professions is expected to grow exponentially over the coming years. So that's a good thing. It'll grow.
Trust me, AA is not doing what a CNA does.
However, the thing I found funny, because a long time ago, I said, I was against AI. That's one of the reasons I won't work in university was they mandated, like, oh, if you come here, you have to build your own network. That's part of our research. I'm like, I'm not doing it. Because I just saw it as a very bad thing. So on the list of jobs that will be gone within the next decade are base level computer programmers. Engineers will still be around, but just your simple, like your basic computer programmers that sit in a cubicle and write code are going to be gone. And I was like, well, if this isn't the biggest frickin' I told you so in history, y'all coded yourselves out of a job. But you were so interested. See, this is one of those lessons where it's like, huh? This is one of those lessons that you have to stop and you have to think. Just because you can do something, is it something you shouldn't do?
It's definitely, I was like, that's really
The answer is no.
No, it's always yes.
No, it's not always yes.
So Brent, this show does not care about solving all these
There's a lot of things you can do. A lot of them you should not do. And also keep in mind, the more computers take over, the worse things are going to get because
See, I
computers are utilitarian.
like when I saw Nebraska
Can you tell me what that means?
No feelings.
No feelings at all.
But I think
You'd be surprised, even when you think you're being logical, how much of your emotions and your human experience goes into your decision. Computers aren't burdened by that. If a computer decides that society will be benefited by calculating the numbers and having positive influence based off killing a group of people, computers will do it. Because all they care about is the final goal and the numbers.
He's like,
So
Yes, we are.
AI sadly does exist, so we're going to learn to use it appropriately.
So do you wish AI never was invented?
Yeah, because we can write simple programs to solve the problems we want to solve.
Do you think there's a cure to cancer that's hidden from us?
yes.
I have no way of knowing. That falls into conspiracy theories.
No, I saw
I mean,
a
that's
TikTok
like, our
yesterday.
government secretly run by lizard people that,
Just saying, we have AI. I feel like AI can help us here.
Well, it's not really AI, it's just a big computer algorithm. It's not like, you know,
Yeah.
it's still just a stupid
I
machine.
was hearing how quantum physics can help you solve cancer
Yeah, some of them are too.
and how mitochondria interact.
iRobot.
no, it's possible, it depends on what
And I
they're
like
looking at.
most of her stuff, but sometimes I'm like,
Communication.
no, I'm not sure
quantum
actually.
communication, that is.
Well, so you're more or less
A
talking about
handful of things,
signals,
but sometimes
simply the body.
now.
And that's usually done by a number of different things. Yeah, it's all quantum mechanics. If you can understand how the signals are generated and sent and how they're disrupted, yeah, you can fix a lot of stuff.
I saw a thing.
Like, for example, in diabetes, you end up with systems that are more acidic than normal. And even though the blood is a great buffer, your interstitial fluid is not. So your interstitial fluid where your receptors are, even though your blood can buffer out a pH change in diabetes, to keep it around like 7.1, down from 7.4, your interstitial fluid can be as low as 6.7, 6.6, which throws off the proton gradient across the cell membrane. So you end up with a lot of problems that way. If you understand the quantum mechanics, yeah, you can start to do some deeper research on stuff.
I don't even understand proton gradient fully.
You've heard of it, right? Please,
Yeah.
please tell me you studied
That's the
proton.
hydrogen.
You're in bio kid.
Don't start with biochem.
Oh, I'm gonna tell Mary that you didn't know.
No, I do know what a proton gradient is.
She's gonna yell at me again.
He's not gonna play games. Sorry.
Okay, so that's what we're gonna do. We're gonna start using AI as a tool. Just make sure you're solving equations fully. You're solving for the variable you're trying to find. And you're translating from what you get from AI into the format we use in class. Do not use anything that we don't cover in class.
Well, I tell Leah that.
And be very, very careful with ChatGPT because again, it's the one that's wrong most of the time.
I won't use ChatGPT.
Okay, let me just tell you, I checked my answers for this last homework that I just turned in on ChatGPT, and it gave me the same answers that I got.
So either Tay is
Are you
wrong
sure?
or.
And I followed the book. I followed the steps in the book to get to these answers. So,
ChatGPT is right about 80% of the time.
well, hopefully it's
20%
right.
of the time it gives you complete crap. You just have to check what it's giving you. And here's the thing, saying, I'm a novice at this topic, and I got these answers, and ChatGPT got the same answers. That's kind of like a circular thing with no actual appeal to an authoritative source.
Well, I followed, the book had
Well, ask
had
Jack, man.
similar
It's okay.
questions, so I just followed the steps in the book.
Yeah.
And
So then your solutions are probably right.
I
And
hope
as I
so.
said, ChatGPT does give right answers. It's just the one that was wrong more often than the other. But I'm guessing you have
Not
a-
good when it comes to
maybe
these
I'm guessing your argument is because you have
yeah.
a subscription. to ChatGPT.
I don't
It's
pay
so
money.
expensive.
Like I've only ever.
They
Have
have
them try to
finals
produce
fee
images for you sometimes.
Oh, they're really bad images.
I don't even wanna talk
I was
about the
gonna try and
images.
make a
Hey,
picture of me and my
go
roommates
do
for our
some research
bathroom
on
and,
AI.
oh, they were making it.
Oh, yeah, AI
I'm
started
not.
producing things.
You're in my bathroom, yeah.
They're called AI nightmares. Look them up. They're horrible.
ChatGPT is really good at roasting you. Upload a picture of yourself and have it roast you. It's funny.
It's really good at roasting.
It's not gonna say anything to me I don't say to myself in the morning.
Was that the?
No, it comes up with ridiculous things.
Okay, so.
That like just.
You like tried to email me, but was not, did you say that to her?
Okay, so we've been talking about the work-energy theorem. Now we're up to a more complete version of it, the work-mechanical energy theorem. So your work there, the MC is non-conservative. So a lot of times you're going to have systems where your non-conservative forces don't exist. So for example, two sources of conservative work done. So gravity does conservative work. And for example, let's talk. We're going to start talking about, in a little bit about springs. So I don't really care how you represent your spring. So we're going to be looking at things where, like, let's say this spring is compressed. So this is the kind of stuff we're going to be talking about. So imagine you have a spring that started at initial X position and is compressed to the final X position. And so that spring is going to store a new type of potential energy that we'll talk about. So if you let that object go, the spring is going to shove it. Okay? Springs do conservative work. Your non-conservative work comes from what kind of forces?
Wait, say that one.
Your non-conservative work comes from what kind of forces?
Gravity.
I just said gravity is conservative,
Oh,
like 1 minute ago.
tension.
So what, give me an example of a
Like
force.
heat, tension,
So heat, yes, where does heat, what kind of force generates heat?
like friction.
Friction, that's a non-conservative force.
Okay.
And so can you give me so it generates heat, energy leaves the system. So when heat is generated and leaves the system, can you give me a general term for those kinds of forces? Dissipated. No, I would remember that term.
Dissipative.
I know who you're talking about.
Mhm.
Can you spell it? Cause I'm not very good at spelling.
Oh, yeah, neither am I.
Yeah, also I
I,
can't.
I'm a math person, I'm not an English, look,
And what is
every
that?
time I write a journal article, I put it into, Grammarly. Grammarly's first response is always, seriously? Like, it's not good.
Dissipative.
Mine's
Yeah,
gonna be
dissipated
dissipated.
forces.
There's
Dissipate.
no R.
What does that mean exactly again?
So dissipated forces
What
means
is it?
they're
Did you-
allowing energy to leave the system. So for example, friction creates heat, heat allows energy to leave the system.
Is it biology?
Dissipative forces are
Oh,
non-conservative.
it's Josie.
Yes. So gravity is conservative, spring forces are conservative.
Friction generates heat,
Mhm.
heat leaves system.
Energy leaves system for heat. Kind of like when I'm in chemistry lab and someone mixes the sodium hydroxide with the sulfuric acid. And I go, did you get a reaction? And they go, no. Did anything change? That's really hot. Did you get a reaction?
I spelled it
No.
right.
Does it reek?
Yeah,
Yeah, I'm switching to.
Matt was here now.
Can you
Next one
just
time I
switch it? So
dropped
I put
it
in my
too much in and like blew up in her nose and it smelled like rotten eggs.
Yeah, I don't do that. Hey, if you ever want to have fun, go into our stock closet and open the cabinet that says ketones on it.
No.
You will feel amazing for a while, like,
Let's go.
if you're not aware, be careful with ketones, they will knock you out.
So what does this dissipative stuff have to do with this?
Because if you don't have, if all you have is like, kinetic energy, gravity, spring, your non-conservative forces are zero, so here,
Wait,
when
spring.
your non-conservative forces are zero, your mechanical energy is conserved. And so what you end up with is a situation where you can look at your initial kinetic energy, your initial potential energy, that's gonna equal your final kinetic energy added to your final potential energy. And so if you think about that, let's just
I
say,
did not know you. Well, that's how you add classes. If you've never used that. Also, why is this? What is
so what delta K is final, the initial, if you do some rearranging,
Is it orange?
Just the one.
How did you get these?
Yeah, but we have two.
you start with your general mechanical energy, work theorem, your delta K plus delta U.
So where'd you get that? Up here, I see, here, sorry.
So- Now, this is kind of a nice little practice, I've seen a few people have issues with it. So yeah, you can see that we get here, we can just go ahead and block in that. So there's that part of the equation. So what happens, so but here, I have a minus and a minus. How do I get from that, this?
Put the -1 on the outside.
Right, if I factor out a minus, that makes both of these positive. Make sure you're keeping track of stuff like that.
Is it red? Is it purple?
Why is this?
I don't think anyone cares what color. Unless it was yellow
Do
starburst.
you
at which
think
point
these
that's
all
just a
taste
bad
the
day.
same? Do you think each color tastes the same?
It's either I don't know.
Exactly.
Like yellow starburst, nasty.
No, delicious.
Pink starburst, awesome.
I agree.
Yeah.
Pink and yellow are my favorite.
Yeah, yellow starburst,
It's like strawberry lemon.
Wait, will you go up real quick? I'm almost done with that one.
Do you like red starburst?
in the middle.
Wait, how did you?
I like Google all the things. It's hard to find.
How did you switch that negatives that way?
Well, because when you pull out, because both of these are negative right now.
Yeah.
When I pull in factor a negative out front, it's like pulling out a -1.
Okay.
So then when I pull that out front, and I bracket these two in, they both become positive.
Yeah, but then why did my UF go negative?
Oh, it's not supposed to.
But you want the dual, that's an associate's degree. Scott.
Thanks.
There should be. What's wrong?
Okay, so
There should be like the dual. it'll say dual.
here we go. Roller coaster halts at the top of, the first hill on the ride. Let's see, after that, the car releases, and no more energy is supplied by an external motor. The cars are moving at 4 meters per second at the top of the first hill and are 35 meters above the ground. How fast are they moving at the top of the second hill? That's 22 meters above the ground. Ignore friction and everything. So, this is one of those times where you don't want to do more work than is necessary. So you might be thinking, oh, I need to figure out energy differences from the top of the first hill to the very bottom, then back up from that to the top of the second hill. No.
I was really thinking.
I wasn't thinking that.
I'm pretty sure you were still thinking orange, green.
I was.
Okay,
It was purple.
was okay. That is the best one.
No, it's the most mid.
Green.
Really? I like yellow. I like red.
Well,
I like all red.
Well, I like black jelly, so,
Yeah.
You like red jelly beans?
Oh, this has red 40 in it.
Like black licorice?
yeah,
Me too.
That's gross.
I really like the good and plenty.
I'm a glutton for punishment. No, they're actually pretty good.
I like black licorice.
Okay, I'm ready. So what do I do?
No.
Okay, so, first off, are there any non-conservative forces? No. So non-conservative work is 0. So here we start with,
Hey, I plus UI.
This is.
so we start here.
Oh.
Then we're gonna start putting in, so this is, remember when I told you about, anything that can become 0 is your friend?
Yes.
Okay. So what we're gonna do now, we're gonna start putting in what these all are. So additional kinetic energy.
Yes, I should.
What's the equation for gravitational potential? GH or MGY, however you wanna write it.
Crazy. Yeah. I just don't know.
We're gonna write out what all these are.
Yeah, no, I get it. You know what I'm saying? Like, I would.
Now, one thing, we have already seen one thing you can get rid of. Yep. That's divided out. Okay. So, and what are we solving for?
VF.
Final velocity. Okay, so I'm gonna go ahead and skip a step and see if we can figure it out.
I don't know. Are you gonna put the derive?
Oh, yeah.
We got there.
If I had to, I would just. Yeah.
Can you get here?
Wait,
If you give me
If you can't get here, next semester, sign up for college algebra.
what if I've already taken it?
And you can't get here, then you wasted your money.
A little less.
Should get a refund.
Drop out is all you say.
Heard the carnival is hiring.
Understand. Understand.
I just got a bad yellow.
Yeah, that too.
Ours got a bad red one.
Okay, so now, the next thing I wanna do,
You can steal the bag.
how do I get the 1/2 done?
Times it by two.
Times two.
Times 2, so I'll multiply 3 by 2, so this one's gonna become
It's just like, it's like campus.
the initial
right?
squared.
It's got-
Then finally. Okay, so this is what I'm talking about. So as you're learning to use AI as a tool, you see how I solved for the final velocity that I'm trying to calculate? You're going to do this. I have seen some homework where people are trying to plug in numbers early to shortcut the system. You're going to do this.
Be like, we're gonna do our job. When I do that.
Because again, AI is going to help you with a lot of stuff. I need to see you get it here. Then from here, once you have the equation for the variable you're solving for, then you can plug in numbers. And so, well, you could have factored out the 2G, but, so your initial height, what was it? So this is where you don't have to figure out, the roller coaster goes all the way down, then that second hill, but you don't have to figure that out. So what was your initial height?
55.
25.
How much money? I might wait. I'm like, I'll do this.
And what's your final height? 22. When you solve for this, your final velocity should be 16.5 meters per second. So the reason you can do this is the work energy theorem, especially with conservative forces, you need to know the initial and final positions. You don't necessarily need to know the pathway taken to get there. Because as you go from the first hill down, your potential energy is going to be translated into kinetic energy. As you start to go back up the second hill, that kinetic energy is going to be retranslated back into potential energy. And at the end, you're going to have a mixture of the two. So this work energy theorem takes account of that mixture you're going to have at the top of the second hill. So you just need to know that height difference between the two hills, and you can get the velocity you're at that height.
If you know you're trying to,
I was just putting this in my
but if it's
calculator.
labs, I usually can't.
Okay, did you get the?
I got the same thing. I didn't get anything you said.
It's a self-coding one, so I-
It's right, okay.
You don't get it. Now we're gonna have some fun. Now, gravitational potential energy. So first off, you see our universal gravitational theorem. We've got force. Gravitation. Look at the difference between the force and the potential. This is a very key,
Inverse.
this is a very key thing to physics. What's different?
It's inverse.
Right, your forces, so your gravitational forces, your Coulombic forces are going to be 1 over r square balls. So if you're reading a book and it says it's a 1 over r square ball, this is what it means. Your potentials are going to be 1 over r balls.
Why is it negative?
We're going to do that. So, you're not going to like it, but we're going to do it.
We don't need to do
There's
it.
only one way to do it.
You want me to get to the, are you gonna show me something to derive to get to this?
I am, but it's not something you're gonna have to reproduce.
Exactly, so why do
I might make you do it now.
Yeah.
I just wondered, sorry, my bad.
So, how do we get the negative? Now, as you're going along, you'll be able to just apply the, and this is a universal format for gravitational potential. You'll see as time goes on, you get to the point where gravitational potential is also going to be that. But how do we get there with the negative? Okay, so when you're calculating gravitational potential, this one we're kind of thinking of as an electron on an atom. You're going to take a measurement at some distance r from the center of mass. And you're going to come to that distance from a place of zero potential. Where is the potential zero?
Height is zero.
So think about this, the ionization of an electron, it feels no more nuclear potential at what distance?
Outside.
How far do you think you'd have to be to feel no more potential?
Double.
Double.
Infinity.
So yeah, that's the same idea when you're talking about ionization potential. An electron, in this case, it's atom. Anything past the ionization point is considered an infinite distance. So anything outside of a gravitational potential well is an infinite distance. And then that's where we end up in the realm of special relativity instead of general.
So is the R the max?
So that's just an area we're measuring the potential at. We're coming there from a distance of no potential.
Okay.
We're coming into some distance r from the center of mass. We're trying to get an idea of how this law works.
Okay.
Now, we remember the work for gravity. Okay. Now that one you remember.
Yep.
So we can't solve it this way. We're going to have to do that distance over infinitely small steps. What do we remember as an infinitely small step? It's a what?
It's a derivative,
It's a differential.
differential.
So yes. So we're going to start with we're going to take infinitely small steps, differential r, getting closer and closer and closer to that distance r. Let's go ahead and make this r prime to differentiate from r. Okay, so always remember, at an infinite distance, you have zero potential.
Is that infinity right now?
Yeah. So how do you think we turn a differential back into a number? We're going to do an infinite sum. Becomes a infinite sum.
Infinite answer.
So our work your limits are infinity to r, and then you're going to have to deal with the dot product on the inside of the integral, but you deal with this the same way. You can say it's
I remember this from not
r
really.
cosine theta. What's the cosine between the what's the theta between the two?
Zero.
0. So this becomes, okay,
It's theta equals 0. is that
theta,
what-
theta equals 0.
Yes.
So now, since we have that, the integrals are always so much neater on paper. I have a hard time with this screen. Now we have a nice integral we can solve. So let's go ahead and put in our gravitational force. So that's going to be what? It's going to be G 1 and 2 r squared r. So the great thing about integrals is anything that doesn't have to do with the ending differential is a constant that pulls out in front of the integral. So what we end up with okay. Now I wrote it that way for a reason. Because technically that's 1 over r squared. But this is going to be a lot easier to understand if we write it as r negative 2, because in calculus, there's this thing for integrals called the power rule. You should have saw that in calculus 1.
Yeah,
Bring it
it's
out in
like n plus
front.
one and
Right,
you put-
Right, so if we have,
Bring it out in front. Now you- What did you say?
so x to some exponential n,
Bring it up.
your solution is always going to be 1 over 2 plus 1. That is the solution using the power rule. Now, the c is a constant of integration because I demonstrated with an indefinite integral. But we have a definite integral, so that constant is going to go away. I just know that if any of our math professors ever saw this, and I didn't put that constant in there, they'd be at my office going, what the hell? So we're going to use that. So in that case, our value of n is -2. So 1 over n plus 1 is going to be what? It's going to be 1 over -1 or -1. So that's going to make this negative. And then we're going to have r -2 plus 1 minus 1. And we have to evaluate from infinity to r. And so we're going to rewrite this. G 1 and 2 over r, evaluated at the limits. And when you do an evaluation at the limits, it's a difference between the two. Okay. Now, if you put this into a computer program or a calculator, it's going to have a fit. Why? Yeah. Dividing by infinity is technically a no-no. The same thing is kind of like dividing by 0. However, we have rules that we can use. So let's say you have this is where we get back to limit theory. There is a rule that says as this x gets smaller and smaller and smaller and smaller and smaller and smaller, the function is going to tend towards what number?
0.
0.
We have to apply this.
So we can zero that out. So that means in our gravitational work, going to be negative G, 1, 2, over R. And then if we put that back into the fact that work gravity we compare the two, so we can say that this is going to go to our kinetic energy. At that distance R is going to be 0. And we now know that our expression for gravitational work so that ends up leading us to the fact that our potential energy we end up with a 1 over R law. So again, I can't make you do calculus on exams or homeworks, but this is one of those times where I'm not just going to make a bunch of asinine assumptions to get to the proper equation. There is a proper way to do it. You can do it from first principles and mathematical argument. Okay, now, so let's see how we can translate between these two laws, okay? Let's take another example. This one I can't expect you to know. We have an object with some height r. So we can say that our delta U you can go there. Well, final would be 0 because that'd be at the bottom. Okay. So your H initial is at distance R. So we have minus mgr. Okay, well, in a previous chapter, we solved for G. What is G? G is your gravitational field. What?
It's a big number.
What's the equation for it as the field? Remember that? I need to give you guys some number variables. Okay, so now we can put that in here. And then we multiply everything together. So we end up at the 1 over R, the 1 over R law for the gravitational potential. So you can translate between the two. Now the one you're going to be using predominantly for calculations is MGH. We're out of time. The whole point is, you don't always have to make asinine assumptions to get to a base. You can start with one
So if you're in the last
fundamental first principle.
There's a trend where you like.